Hello, my name's Martin Woolley. I work for BlackBerry's developer relations team and I'm based in the UK. Today I'm going to be talking about SMS, or text messaging as it's sometimes known, and how developers can exploit the technology from their BlackBerry 10 applications. Now I'm going to start off with a kind of SMS 101, an introduction to the technology for people who may not have worked with it before. Then we'll look at a couple of use cases, and then I'm going to be looking at two sample applications that I've written and released to our GitHub repositories, and using them as vehicles for exploring those two use cases, one known as user-directed SMS and the other port-directed SMS, and the different APIs that are involved. Now, to accompany this video, I've written a knowledge base article which you'll find in the BlackBerry Developer Resource Center. After watching this video, I recommend you review the knowledge base article, which is a more extensive and slightly deeper exploration of this topic. But this is a good place to start, and when we get to the end of the presentation, I'll point you at some other resources that I hope you'll find useful. So let's start with the SMS technical primer. SMS stands for Short Message Service, that's its full name. As I've already said, a lot of people just call this text messaging, although the fact is, SMS is able to handle far more than just text. It's a GSM standard, but it's available on non-GSM networks. It's extremely popular still. Trillions of SMS messages are sent every year. And critically, and this is where it might be particularly useful and interesting to developers, it works on just about every type of mobile phone, smart or otherwise, known to man. So if you send an SMS from one device, be it a BlackBerry or another vendor's phone, you're fairly safe in the knowledge that the device that receives your message will be able to understand it and display it to the user. Let's talk about the very basic architecture of the SMS system as a whole and have a look at what happens when a message gets sent. Now, if there are any telecommunications experts watching this video, please forgive me, this is a drastically simplified description of how things work. Hopefully it will suffice to provide some insight into what goes on when you send a message though. Now in my diagram here on the left hand side I've got a BlackBerry Q10 and I'm going to send an SMS message from that device addressed to another subscriber who happens to have a BlackBerry Z10. Now sitting in the middle there we have a cloud which represents the mobile network to which I am a subscriber, and again for the purposes of this explanation the recipient device also has a SIM card issued by the same network, just to keep things nice and simple. There's a server, or at least it looks like a server in the middle with the label SMSC underneath it. Now that stands for Short Message Service Center, and it's a system, usually a collection of servers in fact, which is responsible for handling SMS messages and their delivery. Let's see what happens now when I submit a message from my BlackBerry Q10 on the left hand side of this screen. So my message gets sent from the BlackBerry device and it travels over the radio link to the nearest cellular network tower, or base transceiver station as it's more formally known. Now as you can see from the call out there, the message has a maximum of 140 bytes available to it as a payload, plus some other attributes of the message, some of which are visible to the recipient of the message and some of which are not. They're kind of system attributes. An example of another attribute that the recipient might see is the sender's phone number, the source address as it's known. The payload contains the message itself, and you may be curious as to why the maximum size is 140 bytes, because you've probably heard 160 mentioned. 160 is in fact the number of 7-bit characters that can be held within a 140 byte space. 7-bit characters in GSM networks are left shifted so that every bit gets used, and you can carry 160 7-bit characters in a 140 byte payload, so that's where that comes from. If you're sending Unicode characters, on the other hand, Unicode characters are always encoded as byte pairs, 16 bits, and therefore the maximum number of Unicode characters you can send are in fact 70 in that same 140 byte payload. Alternatively, you don't have to send characters at all. You can use SMS as a transport for binary data, in which case you have 140 bytes to play with in a single message. Now, we won't go into it here, but you can of course formulate and encode your messages in a way that you can join them up. So you can send a whole collection of messages, each of which is designated as being part of the same larger logical message, and those individual segments each have a distinct number, and they get joined up into a longer message by the recipient handset at the other end. We won't go into that now, though. That's a topic known as concatenated messages. Now, the next thing that happens after our message has been submitted from the BlackBerry Q10 on the left is that it finds its way to the Short Message Service Center and it gets stored there. Now, the SMSC itself has an address, and if you look in the settings for your text messaging application on your BlackBerry device, you'll find that address. It looks just like a phone number, but in fact it's a kind of network address which has the same format. Now, SMSCs are what we call store and forward servers. So when you submit a message that you're looking to send to another device, another person, the first thing that happens is that it will be stored safely on the SMSC, because at this point it's quite possible that the recipient, the destination device, is not even switched on. We don't know that yet. So one of the things the SMSC has to do in conjunction with other network entities is figure out if the destination device is available, and if so, exactly where it is, because ultimately it needs to transmit your message to the cellular network antenna, the base station, which is nearest to the device we're trying to get your message to. So it has to locate you using a location lookup service within the network. And having done so, and having established that the device is on and available to receive your message, it then sends it, and that's what's just happened in that second leg. There we go. Now, it's possible for the sender of an SMS message to track its ultimate fate, to find out if it was delivered, or if not, why it wasn't delivered. This is achieved via something called delivery receipts. And if a delivery receipt has been requested when the message was sent, then as soon as the SMSC has successfully delivered your message, it will generate and return a delivery receipt back to you. Now, a delivery receipt is just a special type of SMS message. If you did request it, and this again is something you'll find in the settings screen for the text messaging application, that you can either switch delivery receipts on or off, then a delivery receipt will be returned to your device when your message is delivered, and the standard application on BlackBerry 10 will respond by displaying a D icon next to your message to indicate that it was delivered. Now, all of this might happen in less than a second. Sometimes, however, it may be the case that the person you're sending your message to doesn't have their phone switched on. Maybe they've gone on holiday, they've left their phone at home, and it's actually switched off for 2 weeks. Now, the SMSC will store your message for a period of time. Now, how long will vary between different networks. It may be days, it may be weeks. As long as it's stored there, though, the SMSC will try and deliver it again, either when the destination device is switched on and says hello to the network to indicate that it's there. The SMSC will say, okay, great, I have some messages waiting for you, here they are. Or it may have a kind of retry algorithm built in, and it will periodically try to deliver your message. So this is where the store and forward part of the architecture comes into its own. So let's now talk about SMS and BlackBerry 10 applications. Now we're armed with some basic kind of theory about SMS. Well, we differentiate between two distinct use cases. We talk about something called user-directed SMS, and these are SMS messages intended to be read by a human user. So if we send a user-directed SMS, it should arrive at the BlackBerry 10 device, it should be stored in their usual SMS folder, their inbox, and the user notified in some way such that they can go and read that message. Now in BlackBerry 10 we have the concept of a conversation wrapped around SMS messages, and we can build conversation structures between a number of people, one of whom is the prime sender and the other is one or more recipients. On the other hand, port-directed SMS is intended to be used by applications which wish to consume SMS messages. And this is where what we really want to do is use SMS as a transport for sending data, often binary data, either from the network to an application on the device or even from application to application. And port-directed SMS messages are rarely seen by the human user. They get absorbed behind the scenes by an application. So let's talk now about user-directed SMS, and we're going to use an application that I've written called SMS Message Service because it uses an API called the Message Service. And again, I'll point you to the whereabouts of the source code for this application when we get towards the end, but we'll use this as a vehicle and we'll have a look at some of the code involved in both sending and receiving SMS messages, and in fact delivery receipts as well. Let's start though with a demo. So I'm running my app on two devices. I'm sending a message from the Z10 on the right to the Q10 on the left. I have a message ID allocated. We can see the message was received, and in fact a delivery receipt returned to the sending device almost immediately. If we have a look in the text messages application on the sending device, we can see the message is there and attributed to Wilma Flintstone. And on the receiving device, it's also there as well. So this is very visible to the user. User-directed SMS makes use of a number of Cascades classes. Now, available to you, you have quite a nice generalized messaging API. Generalized because there are a variety of message types that are supported by BlackBerry. Now, email is an obvious example. BlackBerrys have been supporting email for many, many years. SMS is of course another. And you can do a great deal with SMS, email, pin messages for example, all using the same set of APIs. Now you'll see when we look at code that I've used the account class, the account service class, because different types of messaging are provided by different accounts on the device. That's the concept, that's the term that we use. So there's an account that handles SMS messaging and also MMS. There's an account that takes care of your work email. There'll be an account you've set up for your Gmail account, for example, and so on. And the account service gives you access to the various accounts set up on a given device. There is of course a message service object as well, or class, and that gives us access to generic messaging capabilities. There's a message class which represents a message of some sort. And we have a really useful class called Message Builder that makes it very easy to build messages with different attributes. I mentioned conversations earlier on. Well, we have a Conversation Builder class that lets us build conversation objects. And we have a Message Contact class which represents the recipient of a message, often drawn from our address book. So we have lots and lots of control through this collection of APIs over the user's messaging experience. Okay, let's look at some code. So I've opened the Momentix IDE and we're going to take a look now at the SMS Message Service application. So this is the application that demonstrates how to do user-directed SMS, both sending and receiving, and it also shows you how to receive status reports or delivery receipts. Now this is a Cascades application, so the user interface is written in QML, and there's the main.qml file just there, and the main logic is implemented in C++. So I'm assuming you have some knowledge of Cascades development. We'll just open up the QML file here just to take a quick look at that, and then we'll look at the main code in the C++ class. So I have a simple page with a container with a number of components, some labels, a button, some text fields, and so on. There's even an animation specified for an image view. This is how I make the envelope icon whiz across the screen when I click send to send a message. Most important thing, I guess, is the use of signals. So Cascade sits on top of the Qt framework, and Qt has a great capability known as signals and slots. So I've defined a signal called send message, and as you can see, it's got two parameters, a string which is the text message itself, and another string which is the address, the destination address or phone number to which I want to send my SMS. Now if we look at my button, you'll see that in the onClicked event handler, I check that there actually is an address specified for the message to go to, and then I basically emit the signal by calling it by name here, and I use the parent container object's name as a prefix to the signal name to do that. Okay, so quick look at some QML. Let's now look at SMS message service.cpp, because this is where everything happens. So I'm just going to walk through this code from the top to the bottom, and I'll pause at things that are of particular significance. So I have a few simple C functions that I wrote to translate things like status values into text for the purpose of displaying them in the log or on the screen. So here we have status report type name. There are different types of status report that can be returned to the device. This will vary according to the types of messages that you're sending. Now the one we're expecting to see is this one, delivery report, which is another synonym for delivery receipt. Status reports for delivery receipts will have a status value, and that will tell us what the outcome of submitting our message to the network actually was. Now a value of either 0 or, if we scroll down, 129 will mean that the message that we sent was received by the SME. Now what's an SME? Well, this is the telecoms term for a device really, and it means short message entity. So a device that can process SMS messages has this abbreviated name, the SME. And you can see the various values we might expect to see in the status field here, and all of these come from an etc specification. Okay, so we're now looking at the constructor. A few things happen here I'll point out. We're going to use the message service class and the account service class, so I immediately construct instances of those classes. I also, for convenience, store the phone number that was used when sending a message, and then I restore it the next time the application is run, just so that if you're testing with the same number, you don't have to keep rekeying it into the user interface over and over again. That's how it worked originally, and I got bored with that. I then have a number of signals that I connect to slots. So the first one is not concerned with SMS, it's concerned with logging messages to the screen. This signal is emitted by the QML layer. You saw that earlier on, and when emitted I have connected to a method with the same name in my C++ class here called sendMessage. So emitting the sendMessage signal in QML results in the sendMessage method or slot being called here in C++. Now the message service class has a number of signals that it can emit, and I'm using a couple of them here. The message added signal is emitted whenever a message is added to one of the accounts that the message service is associated with, and this is one way of basically being notified when you receive a message. And of course I'm interested in inbound mobile originated messages arriving as well, and so I essentially connect the message added signal to a method of my own called message received, and you can see there are a number of parameters passed, and the types of those parameters are here in brackets. The other message service signal that I use is called message updated. Now message updated will be emitted whenever something about our message object changes, and in our case what we're interested in is the addition to that message object of delivery reports. Now in the API, delivery reports take the form of objects of type status report. That's the name of the class, and as you'll see when we look at our message updated slot, you'll see that updates to a given message can contain a list of status reports, and that's how we know that we've just received a delivery receipt. Now your BlackBerry 10 device will or may have a number of different accounts associated with it. Now, an account is essentially one source of messages of a given type. Now, we can obtain a full list of all the accounts by using the account service, as shown here. What we're looking for, though, is an account with a specific name, and so we're able to provide a second parameter. And in the case of SMS or MMS messages, the name of that account is SMS-MMS, exactly as shown. That value won't change, so you can rely on using it in your code. Having obtained the account for SMS or MMS messages, I can then extract and store for future use its numeric ID. Now, that value might change, so you should always obtain it by name from the account service first and then store the ID. Okay, that's the constructor. We're now ready to look at the rest of our code. So, let's start here. There's a few things to do with logging there that aren't too interesting to look at. But here's our send message method. So this is the slot method, which is connected to our send message signal. So we click the button in the user interface, it emits the signal send message, and that causes a callback to this method. Now, as you can see, we received two parameters. You saw the counterpart to this up in QML. One is the text that we actually want to send, and the second is the destination address or phone number, or it could be a shortcode of a service. And if we scroll down, there's a bit of validation here. We store the destination address that's been supplied, again for future use, in a queue settings object, so we can restore that when we restart the application. And then we need to do a number of things. Now, as explained in the presentation, with user-directed SMS, we have lots of control over the outcome of sending this message in terms of the chat application, as it's known, the standard text messaging application on a BlackBerry 10 device, and the way that our message gets presented to the user and the way it gets kind of stored and associated with other messages and so on. So the first thing shown here is concerned with a conversation, and a conversation is a concept that groups SMS messages together so that they're associated, they're deemed to be part of a conversation between a given sender, yourself usually, and one or more other recipients. Now, because we're using user-directed SMS, we need to ensure that our message is part of a conversation, even if it's the only message that's part of that conversation. Now, this is straightforward to do. We have a conversation builder class. We can create an instance of that very easily, and we can specify the account that we're looking to create a conversation within. And here's where we use the ID of the SMS MMS account that we got in the constructor code. Now we're going to add to the conversation, in our case, one message contact object. We have to do this as a list of message contacts, but there will only be one member of our list in this particular example. But you can see the power of the APIs here. We could in fact have multiple participants in our conversation. A message contact is simply the class that we use when we're creating recipients of messages. So here we go, we are creating a message contact here. I've hard-coded a name, a kind of user displayable name for my recipient of Wilma Flintstone, happen to like Wilma, specifying the destination address there, and I'm specifying that this is the to address as opposed to CC. Now CC has no relevance to an SMS message. That's something that you'd use for something like an email, for example, which the messaging API also supports. So I add to my list the single message contact object that I'm interested in including in my conversation, and then I specify to the conversation builder the list of participants in this conversation, and again there's only one. I then save my conversation, and I now move on to making the message that I want to send. And just as I have a conversation builder class, I have a message builder class. Now, SMS messages are always sent as attachments to a message. That's just a rule of the API. So we have an attachment class, and attachments have a given MIME type. Now, What I'm doing here is I'm using the message builder class to add an attachment to it, and you can see that I'm constructing my attachment object here. I'm specifying a MIME type of text/plain, and I'm specifying the actual text here. Now the message builder needs to know about the conversation we created as well, so I set the ID of the conversation that I created earlier in this code, and now I create a message object. And as you can see, I obtain my message object directly from the message builder object. This is achieved through the assignment operator being overloaded in the definition of message builder. Now all I have to do is send it, and the message service class has a send method. So I invoke send, I specify the SMS MMS account whose ID I obtained earlier on, and my message object, and I'm returned a message key, which is essentially a numeric identifier for my message, which I can use later on. I could use it, for example, to match against status reports. And I display a friendly toast message to indicate that the message has been sent. So that's how we send user-directed SMS messages. A few stages in there. We create a conversation, we create the recipient of the message as a message contact, and we add it to the conversation. We then create our message, we tell it what conversation the message is part of, and we send it. Now, next I have a variety of methods that are in fact slots that I've connected to signals. So you saw the way I connected signals to slots in the constructor of this class. Message received is used for mobile originated kind of inbound SMS messages. And you can see that message received has a number of parameters: the account to which the message was delivered, a conversation key to indicate what conversation it's a part of, and a message key to identify the message itself. Now I can obtain the message object from message service by specifying the account ID and the message key. So that's quite easy. I now have a message object. I now need to check that it is of the type I'm interested in, that it's an SMS message and not another type like an email. So messages have a MIME type, and we've defined MIME type SMS, which has figurative constants that you can use as shown. I can check that my message is inbound, because if you recall, the signal that I've connected to here is message added. So there are various reasons a message might get added to an account. You might create a new message through the UI, save it as a draft. That would also cause the message added signal to be emitted. So I'm checking it's inbound, which means we've just received the message. I am interested again in double checking that it's an SMS, so I just check it does have at least one attachment, because that's where I would expect to find the message body. Having ascertained that that's the case, I extract the first attachment, and I now have available to me the text, or at least the content of that message body. And attachment objects have a method called data, which returns the payload as a byte array. Now for text, that will be in UTF-8 format, so I can just create a queue string directly from that. So for user directed SMS, I'm assuming that it will be text as opposed to binary content, which I'd expect to be using port directed SMS for. Now message updated is connected to the message updated signal. This signal will be emitted whenever something about a message gets changed, and in our case we're interested in delivery receipts, or status reports as they're known in the API. Now when we do receive a delivery receipt, this method will be called as a consequence of the message updated signal being emitted. So to process message updates in the context of delivery receipts, here's what we do. Once again, we check that we do have an SMS, we check that we have attachments, and then we also have a look at the status reports associated with the message. Now the message object has a status reports method, and if we call it, we get a queue list. That's one of the queue classes of status report objects. Now it could be empty, in which case the size will be 0. If it's not, then we're able to iterate through our queue list and extract the status reports. And all I'm doing here is I'm checking that the status report is of type delivery report, because remember there are other types of status report. that aren't really applicable to SMS. And all I do, if that's the case, is I just log some information to my user interface extracted from the delivery receipt or status report object, including its status, decoded to give me a description. And you saw my simple C method at the top of this source code where I translate status values into a slightly more meaningful text description. And that's all I wanted to show you from this application. I hope that was clear. Let's turn our attention now to port-directed SMS. Now, in this context, port is analogous to the way we use the term in TCP/IP. So a server may listen for TCP/IP packets directed to a particular port. Similarly, as you'll see from what follows, the BlackBerry 10 APIs allow an application to register an interest in SMS messages addressed to a particular port. And in fact, the SMS standard allows messages to emanate from or be sent from a particular source port and be delivered to a particular destination port. And there are some rules about port numbers and the particular range of values that are allowed. Now, once again, we're going to work with Cascade's APIs, slightly shorter list this time. Much of what we do with port-directed SMS is fundamentally the same as the steps we saw for user-directed SMS, but we're going to use a class called SMS transport. Per the name, port-directed SMS was really designed with the idea that applications might use SMS as a transport for binary data. And the APIs allow us to send messages to a specified SMS port and to receive messages addressed to a particular port. And we achieve this through having our application register for a given port when it starts up, typically. Now, one of the consequences of using port-directed SMS is that we will not see the user's SMS folder updated. So this is a real application-oriented messaging approach as opposed to a user-oriented one. Now, I've written an application called SMS Port Directed. Again, that's in GitHub. Let's take a look at the application in use via a short video demonstration, and then we'll talk about the code behind the app and how all that works. So I have my application on two devices here, a Z10 on the right and a Q10 on the left. I'm sending a message addressed to port 16000. You can see both application instances have registered for that port. The Q10 receives the message, and all I do is display the hex decode of the message payload at the bottom of the screen in my kind of scrolling log area there. Now if we look at the text messages application, nothing in there. So again, this is kind of invisible to users, and it's for application to application scenarios. So once again, we're in the Momentix IDE. So let's have a look at the SMS port directed application. I'll skip the QML layer this time. It's very similar to that which we saw for the user-directed case. And let's go straight into our C++ code. So once again, I'll just kind of review the salient points from the top, and this time I'm going to skip things that are fundamentally the same as for the user-directed case. So, some useful functions to translate status values into text at the top. So here's our constructor. Let's have a look at what we're doing here. Well, first of all, you'll notice that in my initializer list, I'm creating an instance of a class called SMS transport. Now, SMS transport is key to using port-directed SMS, and you'll see how we use that later on. And that gets assigned to an instance variable, SMS transport, which is globally accessible. I'm also creating instances of message service and account service, and I'm saving any phone numbers in queue settings and restoring them here just for convenience. Once again, I'm establishing the identity of the SMS MMS account. And here I have a number of signals I'm connecting to slots. So send message once again. But here I have three signals that belong to the SMS transport class, which it can emit, and I'm connecting these to my own slots. And we're going to look at these slot methods in a moment. The first signal is called register result received, and I'll explain that shortly. the second is called message send result received, and the third is called message received. Finally, I make a call to a method of the SMS transport class called register port, and I've specified an argument of 16,000. So what I'm doing here is I'm indicating to the BlackBerry 10 OS that if an SMS message which is addressed to port 16,000 is received by the device, that it should be routed to my application, assuming it's currently running. Now in future releases of the BlackBerry 10 APIs, your application will not need to be running. But today that's the case. So the first thing I need to do if I want to receive port directed SMS messages is register for the port that I'm interested in, and this is how we can associate messages of a given type with a particular application. Now the first of the signals that I connected to a slot was register result received, and I connected it to this method, this slot, on register result received, and it relates to that call to register port. It's an asynchronous process, so I make a call to register a port, I immediately return, but then later on I'll get a call back to indicate whether or not my request to register against that port was successful or not. And it could fail because maybe another application already registered for that port, and there's a kind of first come first served basis for granting access to these ports. You can't have two applications listening for SMS messages on the same port, a common concept of course. So on register result received, what do we do here? Well, we receive the port again and an item of type SMS transport registration results. So we have an enumeration we can check against, and we're really only interested in the port registered result. If that's the value that we get, then we successfully registered for that port. That's good. If we didn't, then something went wrong. So in my case, I'm just logging an error to the screen. Now we'll have a look at how we send port directed SMS in a moment, but associated with sending such messages we have a signal. We have message send result received, and I've connected it to a slot called on message send result received. So here I can basically obtain the message using the message key passed in the slot invocation, and from that I can call the method transmission status, and this will give me a value which tells me whether or not I was able to transmit my message or not. Now sent is the only value I'm really interested in. That said, I have noticed in testing that sometimes I get a result of unknown, which seems also to correspond to things having worked correctly. So I've allowed that as a possible value in my conditional check here. Anything else I consider a failure, and I display a message including the details of the result that I was given. My next method here is also a slot connected to a signal, so I have a signal message received, and my slot is called on message received. Now this is used to receive inbound mobile originated SMS messages sent from a service or another device. So all I do here is do some logging and display a message to the user to indicate that we just received a port directed SMS message. Obviously it was addressed to port 16,000 in our case, and then I obtain the contents of the message. Once again, it's in an attachment object which is owned by the message object, and I log the contents of that attachment's data. So the data method gives me a byte array on screen in hex, because I'm expecting this to be binary data, so I really want to look at the hex value of each of the bytes in that payload. I've also got a method send message which is connected to my QML layer. When I click the button, a signal is emitted. I've connected it to this slot. This method gets invoked. You can see there are three parameters this time, three arguments. We have the text that we want to send. I'm using text rather than binary data in this instance. The address to which the message must be delivered, and the port that I want to use to send it, which doesn't need to be the same port number that I used to when I registered for receiving messages. Bit of validation. And then I use the message builder API once again to create my message, and message contact to designate the recipient or recipients of my message. And finally, I just call the send method of my SMS transport object, specifying both the port and the message. Very, very simple. Now there's a trick you can use to make life even simpler. If you use port 0 corresponds to user-directed SMS. So you can send a user-directed SMS using the port-directed method by specifying a value of 0 for the port argument, and you may find that more convenient. If you do use this approach, this technique, then the message you send should not appear in the user's inbox anywhere. And the rest of our class here is concerned with things like logging in user interface. So that's everything that you need to know about port-directed SMS. It's quite straightforward, and the key points are: you use a class called SMS transport, which we did not use for the user-directed SMS use case, and there are a number of useful signals such as register result received, message send result received, and message received that we can use with port-directed SMS. Finally, to ensure that you receive messages that are addressed to a particular port, you need to use the register port method of the SMS transport class. And that's it. Let's return to our presentation. So this more or less brings us to the end of our video presentation. I hope you found this useful and interesting. I'll leave you with some pointers to other resources. Number one, top of the list, are the Cascades API documentation themselves. I've given you the link there that will take you straight to the reference documentation for the API. There's also a knowledge base article which I mentioned earlier on. This is in the Developer Resource Center, and there's the link for it. You'll find it somewhere in that list, and this is a much deeper and more extensive review of this subject, so I recommend you read that next. You'll find code samples, the two applications that we've been reviewing, in our GitHub Cascades Community Samples repository, and the link is there on screen. Finally, if you have any questions about this subject, I'd be glad to try and help, and you can contact me on Twitter. My handle is there on screen, it's at MDWRIM. Thanks very much for listening, and good luck with your next project.